I could see I got Adam up now. You gotta add 'em up now. But don't just add 'em once, you gotta add 'em twice. 'Cause there's more like it on the other side. You gotta add 'em up now.
Hello, guys, and welcome to the Kearney Math Show. Thank you all for tuning in today. On today's episode of the Kearney Math Show, we are going to be featuring mini lesson 3, surface area of rectangular prisms. So before we get started, go ahead and write entry. This is actually entry number 4 at the top of your mini lesson, and go ahead and read the learning goal. Okay, our learning goal today is by the end of today, I want you to be able to explain to someone else how you would find the surface area of rectangular prisms. So over the past week or so, we've been talking about volume of prisms and pyramids, and today we're now segueing into something called surface area. So volume we talked about was the inside of a figure. So when you hear the word surface area, let's break that down. When I think of surface, I think of the outside of something. And when I hear the word area, well, we know how to find the area of things. So that is exactly what surface area is. We're finding the area of the outside surfaces, and then we're going to add that up. So surface area is the sum of the area of all the sides of a 3D figure. So the sum of the sides of a 3D figure. So where in the real world would you need to find surface area? Where would you need to cover the outside of something? Okay, when I'm looking around my room right now, I'm actually thinking, well, if they were to come in here and paint, I would need to find the area of the wall, so the surface area. If they wanted to come in and put tile on the floor, I would need to know the area of my floor, so the surface area. For me, I love birthdays and I love giving gifts and getting gifts. And so surface area, you could also find when you're talking about the gifts. So if you're wanting to wrap a present, so this picture here, we have Karen, and she has bought this beautiful gift for her family. I mean, goodness gracious, look at that box. I can only imagine what's inside of it. And here's the problem. She's running really low on wrapping paper. So what we've got to do is we've got to figure out exactly how much wrapping paper she's going to need before she gives this gift. And you notice she's giving it to her siblings because yesterday was National Siblings Day, if you didn't know. So she's giving a gift for National Siblings Day, and we've got to find out how much wrapping paper. So for me, just to break it down, what I like to do is I like to label my pictures because I'm a visual person. So I'm going to label this the front, I'm going to label this the top, and I'm going to label this the side. Okay, and we're going to go through and we're going to find the area of each of those surfaces, because surface area is the sum of the area of all the surfaces. So if I look at the front and I just sketch the front, I see that the front is a 4x2 rectangle. And so if I wanted to write the dimensions, that would be 4 centimeters by 2 centimeters. So the area of that would be 4 times 2 is 8 centimeters. And remember, area is measured in square units. Okay? Well, think about the back. What do you think the back would look like? That's right. The back would actually look like the front. So the back would be a 4x2, 4 centimeters by 2 centimeters. And so then it would have the same area, 8 centimeters squared. Okay, so we're just going through and we're finding the area of each surface. Now, if I look at the left side over here, if I were to sketch that, that would be a little bit longer, still too high. So let's see, we would have 6 by 2. So 6 centimeters by 2 centimeters, which if we find the area of that, 6 by 2 would be 12 centimeters squared. Okay? Now the right side, what do you think the right side would look like? The right side would look just like the left. So we would go through and we'd say that's also 6 by 2. So 6 centimeters by 2 centimeters, which would be 12 centimeters squared. Okay, we've done the front and the back, the two sides, and now we have the top and the bottom. So the top, if I go back up, the top is 4. I see 4 across and 6 back. Okay, so I'm going to do a 4 by 6. So 4 by 6. And to find the area of that, same thing, rectangle, length times width. So 4 times 6 is 24 centimeters squared. And then the bottom, if you can imagine what that bottom would look like, the bottom would look just like the top. So 4 by 6. And it would have the same area as the top. Okay, so what I've done so far, guys, is I've gone through and I found the area of all the surfaces. So, goodness, that seems like a lot of work, right? It seems like we did a lot, and a lot of the numbers were the same. So what I want you to do is I want you to look on the right-hand side, and let's answer a few questions. What do you notice, looking at your table, what do you notice about the relationship between the front and the back? Go back to your table. Look at the front and the back. What do we know? What do we get for both of them? They were both 8, right? What did you notice was the relationship between the left side and the right side? They were both 12. And what did you notice about the top and the bottom? They were both 24. So for me, I noticed that the front actually equaled the back. I noticed that the left actually equaled the right. And I also noticed that the top equaled the bottom. So did I really have to go through and find all of those? So our next question says, using this relationship, do you think there's a shortcut? Is there an easier way, instead of having to go through and find the front, back, top, bottom, side, and then adding all 6 of those together, is there an easier way? So for me, I think if I know the front is the same as the back, what can I do with the front to show that they are actually two just like that? I can multiply times 2. And if I know the top is the same as the bottom, well, I can go ahead and take that and multiply times 2. And if I know the side is the same as the other side, I can take that and multiply times 2. And then how would you find the total surface area? What would you want to do with all of those? Well, our definition said it's the sum. So I would actually go through and I would add. Okay? So let's take what we just learned and let's make up a formula. Let's make up something that works for all of these. So before we do that, let's draw a picture. Okay, so I've got a rectangular prism. And remember we said prism was something that repeats the shape, so we've got this rectangle throughout. Now I'm going to label it front, top, side. And today on your notes and your practice, I want to see that you're labeling every problem because it's very visual. You want to make sure you're getting it all, okay? So we said find the area of the front, and what do we know is just like the front. The back, so we're going to multiply times 2. Okay, we find the area of the top. What do we know is just like the top, the bottom, so we're going to multiply times 2. And then we're going to find the area of the side. And what do we know is just like the side? The other side, so we're going to multiply times 2. And our final step is we're going to find the sum, because surface area is the sum of all the surfaces. Okay, so if I need to go back and actually, I need to find the sum of all of my surfaces. So I can go through and I can say 8 plus 8 plus 12 plus 12 plus 24 plus 24. And I can tell Karen that she needs a total of 88 centimeters squared to wrap that beautiful box that she's going to give to her siblings. And I know they're going to be so excited. Okay? So I'm going to get you started with one practice problem, and then I'm going to let you work. Okay? So if you'll go to the back and look at number 1. Number 1, I'm going to go ahead and label the front, the top, and the side. And I'm going to come over to the side and I'm going to make me a list. I'm going to find the area of the front, I want to find the area of the top, and I want to find the area of the side. Okay? So I'm going to find the area of each of those. And I'm going to stop right there. What I want you guys to do is I want you to continue with this problem. I want you to go through and see if you can find the area of the front, find the area of the top, and find the area of the side. Okay? And then remember at the end, you're going to find the sum of all the surfaces and see if you get it correct. All right? All right. Good luck, guys. If you have any questions, go back and watch the video again. Write down any questions you have. And when you come to me, I want to hear one thing you've learned and one question you still have. And I really want to see that you're labeling front, top, side, and showing all of your work. All right. Good luck, guys. Peace out, Rainbow Trout. Love you, mean it.